Hello everyone, and welcome to another reverse engineering video. I was very curious for a while to understand how code obfuscation can be done for ELF files on Linux platforms. In this video, we'll play with a GCC code obfuscation plugin, see how it works, and then analyze the generated binaries. The latest documentation for creating GCC plugins is available at this URL. And there are other materials about creating GCC plugins, like this one here, and a few others. The most interesting I found is Goat project, GCC Obfuscation's Augmentation tools. It's a collection of different plugins, each performing some kind of code obfuscation. The plugins are designed for GCC 4.9, which is actually a little bit old. So before getting into the fun stuff, we need to get the GCC 4.9 toolchain and header files. Here are some quick steps to do that. I'm installing the add-apt-repository command and then add a new repo. After that, just update the packages list and get the GCC and G++ version 4.9. And also, don't forget to download the plugin dev package, which contains the header files needed to compile new plugins. Next, clone the Goat project from the public GitHub link. To avoid typing long binary names, temporarily change the GCC compiler links to point to the version we just installed. Let's verify the links and versions. GCC links points to the 4.9 version binary. We will see in another video how to adapt the plugins for newer compiler versions. We've done the same for G++, although we're not using it just yet. Next, let's play with some obfuscation plugins. JPanic looks pretty interesting. And the author was kind to create a detailed README file. According to this, it will generate random junk instructions and functions and inserts them at compile time throughout the binary. Let's play with this a bit and compile the test application in the test.c source file. It compiles successfully. Let's use a different name so we can generate multiple output files. There's an error here, but it doesn't matter. I'll clear everything and start from scratch. Each of the plugins in this project can be compiled individually by running make command in its base folder. Clean the existing files and rerun make. This is helpful because we see the exact commands run under the hood. Notice that G++ is used. We needed that symbolic link. Okay, we can specify the maximum number of junk instructions and functions that will be inserted randomly in the code, 1000 in this case. This number represents a maximum amount and is not guaranteed because it depends on the program logic. If you're curious, have a look at the source code and see what type of junk instructions are constructed and how. We'll create 3 different output files to better observe the logic. Check their hashes to prove we have 3 different files. But they should all work the same and produce the same result, as expected. I'm switching to another VM with analysis tools, IDA and GDB debugger. Quickly check the source code, very straightforward. The main function calls a dummy function that just prints a string. We'll start with GDB for a quick overview, then move on to add-apt-pro for some heavy static analysis. Set up 2 breakpoints in each of those 2 functions using b command, then run the first sample, junk1. Great, we land in the main function, advanced a few instructions, and here's the code to our function. Notice the arithmetic junk instructions inserted, the multiply after the call to puts. Let's move on to the second file, junk2, similarly open it in GDB, set up the breakpoints and run. This one is pretty interesting as it contains 2 new dummy functions automatically generated. Let's see how all these look in add-apt-pro. Open the first one we've looked at. Cool guys, pretty exciting so far. Let's see together what we can find out. Notice the junk assembly instructions right after the call to our function. If we check the instructions manually, this whole block of code over here is completely redundant. Some registry assignments and arithmetic operations, but their result is not used anywhere. Same thing in the custom function. There are a few redundant instructions after the call to puts. This is a very short program, but in larger ones the effect would be proportional. Let's check the second compiled binary. This is interesting because additionally to junk instructions, it also creates dummy functions. Notice 2 of them, with some junk code in between. But what about their code? As expected, more redundant arithmetic operations. Our function is unmodified. Compare its code with the modified code in the first junk1 binary. Now it's a lot shorter. Let's have a look also at the third file, which actually is very similar with the first 2. Different instructions, but the pattern is the same. Our small function is almost unchanged. We probably need to play with larger programs to observe considerable differences. To conclude, we've looked at the first obfuscation plugin called JPanic. In the next video, we'll play with a different kind of obfuscation for hiding static strings. If you like this video, please subscribe to our channel. It will help us grow and create more videos. Thank you!